Hello everyone, my name is Jim Brian Sampson, and this is my presentation to Project Scope and Dataset Techniques and Models. The project description has not changed, so it's still focusing on distinguishing between normal traffic and an attack. So I achieved this by analyzing past data that has successfully captured attacks and the features that they had carried. These features will point out the characteristics of attacks, in which I will analyze the services, protocols, and data packet aspects of the datasets. The project scope has not changed throughout the project. I am still trying to focus on the data flow from the source to the destination from the first primary dataset. The data analytics problem that I am analyzing is how an NID or network intrusion detection system determines what is normal traffic and what is an attack based on captured network traffic. Network traffic and data packets flow from nodes to nodes, so the purpose of this project is to focus on what goes on during the flow of traffic as it travels through the network from the source to the destination and from the destination back to its source. This graph represents a top-down look of my project's primary end goal. As you can see, we have a user, a system administrator, the information holder, and the intruder who attempts to intrude through the network. So the way this works is that a user or customer would utilize a computer, laptop, or a cell phone, and they would send a request through the internet, which will be in the form of a data packet. It will hit the internet, hit the router, go through the switch, and into the server of the information owner themselves. So we have these system administrators who monitor the network for any intrusion or any attacks that would occur. An intruder or hacker that has a purpose to do damage or attack a network will simply ingest their attack in any of these points throughout the packet's duration's lifetime through the network. So it's a job of the system administrator to catch these, but they rely on the NIDs themselves. But the purpose of my project is to see that if we can capture that without the NIDs. I will be utilizing 3 datasets for this project, which will include the KKIS 2017, the WHAT 0919, and the KDD ID. The first dataset has variables that focus on the data packet's transfer. The second dataset focuses on what type of attack had occurred, and the third dataset focuses on what happens between the transmission of the data packet and what attack had highlighted throughout its travel through the network. The first dataset has a total of 1,358 missing variables. The secondary dataset and third dataset do not have any missing variables at all. The primary dataset has 72 variables with 8 different individual datasets within its dataset itself. However, there are the same variables but with different values. The primary variable to be used is the destination port. The first primary dataset focuses on the data packets itself, so the source, the destination port, the total amount of packets, the length, the forward packets, the backwards packets, and its bytes in bulk that was used during this transmission. The secondary dataset has a total of 38 variables and about 125,973 cases. The primary variable that we'll be using is the X attack. This dataset focuses on the data packet that was encapsulated in an attack, so it will focus on the protocol type, the urgency, and the priority of the packets themselves. The third dataset consists of 42 variables and 311,026 cases. The primary variable to be used in this dataset is called normal. This dataset focuses on the connection points that the data packets have traveled through. This would include the duration, the type of protocol, the type of source, and so on. One of the predictive models that I will be utilizing is the linear regression model. Here I have an example of one of the models I have created for one of the data sets. As you can see, this captures the intercept, the estimates, the standard errors, the t-values, and the p-values. Here's another example of another data set that I have captured as well. This will continue to go on through all three data sets until I can find correlations between all three. A second predictive model I will be utilizing is neural network models, which will capture the relationship between variables and the primary variable themselves. Here I have examples of plots that have been generated from RStudio, as well as the standard errors and thresholds and steps needed to create each model. Here I have examples of some Tableau visualizations I have created. Here's an example of the weekly capture of the first primary data set and its packets used per day. This is also another one, as it captures which day of the week had the most average packet used. Here's another example of a few more visualizations I have created. Some of these have correlating information between two different data sets. This was captured from the secondary and this was captured from the third data set. So I have found at least one correlation between the two. Lessons learned. I have learned which data set had the most meaningful data that I can use. The methods that I had to choose between were kind of difficult at the beginning because I didn't know which one would actually apply to all three data sets at the same time. But however, in the end, I decided to use neural networks and linear regression. The objectives have changed over time, but however, the primary purpose of the project remains unchanged. Tableau, I had to revert back from using one booklet for the entire project to several booklets because it was unable to launch in the beginning due to the amount of data included from all three data sets. I also have learned that instead of using the discretization and impute methods, I decided to just use conversion, as in using the as.integer conversion to be used to create the models for all three data sets. References I have used so far for my project. If you have any questions, please let me know or email me. Thank you very much.